Hi everyone, in this video we will talk about logistic regression. We are going to solve three problems. The first one is that when to use logistic regression model and how to fit a logistic regression model using R. The last question will be after you get the coefficients estimations, how should you interpret the results? So before we go ahead and answer the questions, let's look at some examples. So the first one is, are students with higher GPAs more likely to get into medical school or not? The second one is, if you carry a heavier backpack, are you more likely to have back problems? And the third one is a single mother more likely to get married to the birth father if their child is a boy rather than a girl? So let's look at these three examples and think about what they have in common. First of all, the first question, we are thinking about how we can use GPA to talk about whether the students get admitted into medical school or not. So apparently the response variable here is admitted or not, yes or no. And the second question is that, can you use the weight of the backpack to think about you are having back problems or not, yes or no? So the third question is that, can you use the sex of the baby to predict whether the mother is going to get married to the birth father or not? So yes or no. The three questions, the three examples have one thing in common. Their response variables are binary response variables. Binary means there are only two possibilities, either this way or that way. So these are typical questions that can be solved using logistic regression. So you can see for logistic regression, your response variable must be a binary response. And then you are regressing that response variable on explanatory variables. Like that variable can be quantitative, it can be categorical. So it can be quantitative like GPA, weight of backpack, or it can be a categorical variable or even a binary variable, which is like the sex of baby. So you can see here, these are the situations that you can use logistic regression. And for logistic regression, we call it logistic regression because it is using a logit transformation. You can see on the right side, you have the same format as a multiple linear regression or a simple linear regression. So for a simple linear regression, we use y equals beta 0 plus beta 1 x. And in a logistic regression, we are using a logit transformation, which is log pi over 1 minus pi. And they have exactly the same thing on the right side. And one note here is that you can build a logistic regression considering more than one predictors. Like you can make it beta 0 plus beta 1, x1 plus beta 2, x2, or different combinations, variations of several predictors. And you can also consider just one predictor, the easiest format like this one. So that's my first note. And the second note here is that for logistic regression, we are not predicting 0 or 1 directly. We are predicting pi, which is the proportion of ones at any given x. So we are actually predicting pi, which is the proportion of ones. So now we are going to use an example about medical school acceptance to practice on logistic regression. So you can take a few minutes to read through this question here and to think about what we are talking. And the basic question here is that how to model the acceptance on medical school. Like we have a variable in the dataset called acceptance status, which is accepted or denied, yes or no. And we have GPA, MCAT scores, and genders. So those three variables are available to us, and they can be considered as possible predictors. So how can we model the acceptance status, the binary response, using the given variables here? Then, if you haven't done so, let's install a package named as stat2. S and D are capital letters. So you want to install that package first. And then, as it is installing, you can type library function, and you can type that package name within the library function. This is to load the package. And run that line. So the data we are going to use is called MedGPA, and you can just use data function to get access to that data. You can look at the right side here as you click run. So you can see the data is actually showed here, and you can see we have accept different letters, acceptance, which is no or yes. And we have sex, BCPM, GPA, a lot of different variables are available to us. And one thing you can do is to use a question mark on the MedGPA so that you can have an explanation on all the variables we have. Like we have the status of accept. We have acceptance, 0 is no, 1 is yes. And we have BCPM, what is it denoting for? We have GPA, we have verbal, physical science, writing, and so on. All these variables are available. And what I want to do is to check the variable names and print them down below. To question first, we are going to talk about how to model on acceptance, which is yes and no, using GPA. So you can see acceptance is 0 or 1, and GPA is a quantitative variable. So how to model on 0 and 1 using a numerical variable. And first thing first, I want to draw a plot to let you know what is happening. So let's use acceptance, and then tilde, and then GPA, and the data equals the dataset name here. So you can run that plot quickly, and you can see the graph. So GPA spreads from like 2.5 to 4, and acceptance is only taking values 0 and 1. So let me build my first linear model just to give you a bad example. LM and everything is the same as it is in the plot function. So that is LM1, and then I add that model line to the scatter plot on the right side. So you can see my predicted acceptance is all over the place. It can be 0, it can be 0.2, 0.4, 0.6, and even 1. Or it can go beyond, right? It can even be a negative number. So that is not reasonable. You cannot predict acceptance 0 and 1 using a number that is negative or greater than 1 or any number in between. That's why we want to talk about logistic regression, and let's see how should we build that model. So logistic regression is using the function GLM, but everything, the syntax is exactly the same. So we are going to use Y versus X, set up the data set, and then we are going to use family equals binomial. So we want to set this up because we are talking about a model that has binary response. Binary means 0 or 1, yes or no. So let's run that line. And you can see we have coefficients estimated here. We have intercept, GPA, and we have other values here which we will not talk about right now. But we can definitely write out the model, which is log pi over 1 minus pi, that's the logit transformation, equals beta 0 estimate plus beta 1 estimate times GPA. So this formula gives us something. Like, for example, if you know the GPA equals 3, you can actually run this line and you plug in number 3 here and you run that line, you are getting negative 2.845. So this is the value for the log pi over 1 minus pi. And if you get that value, then you can continue. Let me write down what we can do here. So if you have log pi over 1 minus pi equals the value negative 2.8, then you know if you take exponential on both sides, you are getting pi over 1 minus pi equals exponential e to the power negative 2.8. So let me calculate that number here. And this value is now 0.06. So this value is 0.06. And if you know pi over 1 minus pi equals 0.06, then you can get the value pi by doing like multiply 1 minus pi to the right side. You are getting 0.06 minus 0.06 times pi. And then move this to the left. You are getting 1.06 pi equals 0.06. And then you can derive your pi, which is 0.06 over 1.06. So let's calculate this value here. 0.06 over 1.06, which is 0.056. So that means for students with GPA being 3, the probability of getting acceptance is 5.6%. So that is what we mean using the logistic regression formula. So we are getting the model here, and this talks about how should we use that model. Can you get predictions on something, on the probability of being accepted? And then we can continue. So we know this is log pi over 1 minus pi. And you can also think about a definition that is called odds. So odds is defined as the probability of success over the probability of failure. So this success and failure doesn't mean a real success. We are talking about the probability of getting a 1 over the probability of getting a 0. So that is named as odds. So you can think about this formula as log odds equals this. Log odds equals this formula. So you can interpret the coefficient as GPA goes up by 1, the log odds increase by 5.454. So that's what we mean for this coefficient here. And moreover, you can think about it as GPA goes up by 1, the odds increase by log odds increase that amount, then the odds will increase by the exponential of that number, which is 233. My second question here is how to predict acceptance using GPA and MCAT and sex. So again, I want to get the variable names correctly. So I type the names function to get all the variables here. And then I'm going to use GLM function. I'm using acceptance tilde. And then I have my GPA, MCAT, and sex. And data equals MedGPA. And family still equals binomial because my response variable is a binary response. So I can run this line. And I'm getting a model with all these coefficients estimated here. So what you can do is to call it GLM2 and run that. And then you can use the summary function on that GLM2 so that you are getting like the summarized results in a table format here. So you can see we have z value, which is for testing each individual coefficient. And we have null difference and residual difference here, and we have AIC value. Now let me share some other important functions. For example, you can do coef, which is for coefficients, on GLM2. And you can get all the coefficients typed here. You can see they are the same as the estimate column here. And if you want to talk about the odds change, you can do exponential on the coefficients of GLM2, the model we built here. So if you take the exponential, we are actually taking exponential on each coefficient, and we are talking about the odds change, but not the log odds change. For example, the GPA exponential of GPA coefficient is 170. So 1.7 times 10 to the power 2, which is 170. So that means controlling the MCAT and the sex of the students. As the student's GPA goes up by 1, the odds of the student get admitted into medical school will increase by a factor of 170. So that's what we mean by exponential of the coefficients. And another thing you can do is to do model comparison. For example, I can build a model called GLM0, and I can do GLM on acceptance with no predictors. And I let the data equals MedGPA, the family equals binomial. So this is my GLM0. And this is my GLM2. So if I want to know which model is better, I can run ANOVA GL the test equals cos square test. And I can run that line. So this is for running a test using the divans and to check whether my model 1 is better, or whether we are talking about whether model 2 has very significant predictors or not. So you can see the p-value here is very significant. That means my predictors in this model 2, actually some of them at least, are very significant. So also you can build a GLM1, and you can let the model to be acceptance on GPA only. So this is my model 1, and my model 2 is the same. Let me copy it here. So this is my model 1 and model 2, and I can compare these two models using ANOVA function. And then I specify the test to be cos square. And I can run that line, and I can get a p-value that is a little bit smaller than 0.05. So that means model 2 is better than model 1. We are rejecting the first model here, and we are thinking maybe at least one of the two variables here are significant.